Before we implement our threads library, I want to clarify some important distinctions between kernel-level threads, such as pthreads or POSIX threads, and the user-level threads that we'll implement as part of this project. In both cases, let's say, we have multiple processes, each with multiple threads inside them, and of course we have a process-level scheduler inside of the kernel. The key difference is where the thread-level scheduler lies. For kernel-level threads, the thread scheduler is inside of the kernel, and hence it can schedule multiple threads from the same process on different cores. Just as importantly, when one thread blocks, a kernel-level library can schedule another thread from the same process. In the user-level thread setup, the kernel doesn't even know that a process has multiple threads, and hence can't schedule them on different cores. When one thread blocks, the OS won't know that there's another thread from the same process that it could schedule, so the whole process necessarily blocks. Remember that for user-level threads, the thread scheduler is actually a part of the process itself, which is not the case for kernel-level threads. Okay, so let's review the comparison here. In kernel-level threads, we have thread concurrency within a process. That's not possible for user-level threads. Remember that the kernel didn't even know that the process had multiple threads. Another difference was that at the kernel level, only an individual thread blocked on a blocking call. For a user-level thread library, however, the whole process necessarily blocks. And because of these advantages, kernel-level thread libraries have become the standard. User-level thread libraries, on the other hand, are easier to implement, which is lucky for us.